Hello everyone. Today I have started class 11th maths. In this video we will discuss chapter 5 of textbook. It is complex numbers and quadratic equations. Here the quadratic equation, you have heard this name in your 10th class. First we will write here what we know about the quadratic equations. First thing, in 10th class we know the general form of quadratic equation is ax square plus bx plus c equal to 0. A, b and c are real numbers, and we know the quadratic equation have two roots which are the solutions of quadratic equation, and these two roots may be real roots, and sometimes in few equations our solution is roots does not exist. So when the two roots are real roots, that time the values of the x in this equation are real numbers. Real roots means values of x are only the real numbers. This is about the real roots. When roots does not exist, it means in our 10th class no real number is the value of variable. This thing we need to understand. Why in the 10th class we are writing roots does not exist? See here. First see the definition of the real numbers. What are real numbers? In 10th class the definition we studied, that is all rational and irrational numbers. All rational and irrational numbers are real numbers. One more definition is the square of real number cannot be negative. A square of real number cannot be a negative number. See here, what is this? Let's take the example x square plus 1 equal to 0. This is the quadratic equation and we will try to solve the equation. If we will solve it in the 10th class, see what we will do. I will write here, this implies x square equals to this plus 1 will transpose it in the RHS, that is it will become minus 1. So here x square is equal to minus 1. It means the square of some number is negative. I will write its answer, since square of any real number is not a negative number, therefore it does not have roots, or I can say roots does not exist. This is the solution of this equation. But when I am reading this equation, when I am studying this equation in the 10th class, but in actual sense it means in a real system of numbers, this equation will not have roots. In a real system of numbers, no roots are there for this equation. But so there is the need to extend this real system of numbers. What does that mean? We denote root minus 1. Whenever we have root minus 1, it is written as like this I, and it's read as iota. So root minus 1 is iota. So I can write this equation once again. x square plus 1 equal to 0, x square equal to minus 1, x is equal to plus minus root minus 1, which is equal to plus minus iota. So I can write the solution of this equation is plus minus iota, but this iota is not the real number, this is the imaginary number. This is imaginary number. In 10th class we have also studied the discriminant. Its value is b square minus 4ac. We have studied if discriminant is less than 0, it means if discriminant is negative, that time the equation will have no real roots. That means now in the 11th class we can say if discriminant is less than 0, the equation will have roots, but the roots are imaginary roots. Understand this discriminant to b square minus 4ac. If this value is 0 in 10th class we have studied, then the equation will have no real roots, or we can say the equation in 10th class no real roots will exist. But here in the 11th class we will say if discriminant is less than 0, the equation will have imaginary roots. Now we will understand the complex numbers. Complex numbers are defined like this: a number of the form a plus iota b, where a and b are real numbers. This number is known as the complex number. Understand clearly. A number in the form of a plus iota b, where a and b are real numbers, is defined to be a complex number. For example, 2 plus iota 3. This is the complex number. Once again we can take example 3 plus iota root 2. This is the complex number because this number is in the form of a plus iota b. Here a and b should be the real numbers. See here, a is here 2, b is here 3. They are the real numbers, and 3 is here a and b is here root 2. They are the real numbers, and this iota should have. So if we will see the terms, there are two terms. I can write here z is equal to a plus iota b. A complex number z is equal to a plus iota b. This is first term, this is next term. So this term, since this does not contain iota, this is called the real part of complex number and is denoted by REZ. This part is called the imaginary part. And is written as or denoted as IMP Z. This is the real part and this is the imaginary part. Two complex numbers let z1 is equal to a plus iota b and z2 is equal to c plus iota d. These are the two complex numbers. They will be equal if a is equal to c and b is equal to d. If a is equal to c and b is equal to d, then we can say z1 is equal to z2. That's the two complex numbers will be equal. For example, if we have a question 4x plus iota 3y equal to 8 plus iota 12. These are the two complex numbers. They are equal. We need to find the values of x and y. See here, the two complex numbers are equal. It means real part of this number is equal to real part of this number. Imaginary part of this number is equal to imaginary part of this number. See here, here is real part 4x. I will write 4x equal to 8. It's real part. And here is imaginary part 3y. Here is imaginary part 12. I can write 3y equal to 12. So x is equal to 8 by 4, x equal to 2. Y equal to 12 by 3, y equal to 4. So these are the values of x and y. Now we will briefly understand the square root of a negative real number. We know that iota square is equal to -1. And if we will write iota is equal to, that's root -1. So we can say that the square root of the -1 is iota. That's here. Similarly, if we have minus square root of -3, how we will solve it? We can write root -1 into 3, that is root -1 into root 3. We know root -1 is iota, so I can write iota root 3. Similarly, if we have root -21, how to write it? Write it in the form of iota. I can write root -1 into 21, which is equal to root -1 into root 21. That is equal to iota root 21. Now look at the example 2 in your textbook. That is example 2, which is express the following in the form of a plus b iota. Express the following in the form of a plus b iota. This is the example 2. The first part is -5 iota into 1 by 8 iota. See here, 1 by 5 into -5 by -5 is equal to -5 by 8. Iota into iota is iota square. We know iota square is -1, so -5 by 8, instead of iota square we can write only -1, which is equal to 5 by 8. So I need to write this number in the form of a plus iota b or b iota. What I will do, I will write 5 by 8 plus iota 0. Here a is 5 by 8 and b is 0. Dear students, my suggestion to all of you is that please see the examples till example 4 on your textbook and try to solve them. And if you have any doubt among these examples, you can ask me, and in the next video we will discuss the modulus and the conjugate of a complex number.